For my next problem that I got from the test, it's going to be talking about the laws of thermodynamics. The first law is energy is not created nor destroyed, but because this is somewhat untrue, energy flows from one to the other. That's how we get into the second law. And basically the second law, what it says is that entropy is equal to disorder. The entropy of the universe is always increasing. So the more energy dispersal, the more entropy. The way I like to think of the second law is having a messy room. So if your room is clean, it is easier to get, it will get messier over time. And that is entropy is equal to disorder, basically entropy. So as your room gets messier over time, it cannot get cleaner unless you clean it, but it can get messier without you even pretty much trying. And then the third law of thermodynamics is a perfectly crystalline solid at absolute zero has an entropy of 0. And the Gibbs free energy is basically telling us about the spontaneity of a process. So the question is, the second law of thermodynamics, what does it indicate? So enthalpy of the universe is always positive. Enthalpy is 0 at equilibrium. Entropy of the universe is always positive for a spontaneous process, or entropy of the universe is always positive all the time. So I look at my first one, enthalpy of the universe is always positive. So because it's talking about enthalpy and not entropy, then I'm gonna automatically cross that one out. And then enthalpy again is 0 at equilibrium. I never talked about enthalpy. And then entropy of the universe is always positive for a spontaneous process. Because we are talking about Gibbs free energy tells about the spontaneity of a process, then this is definitely an option. And entropy of the universe is always positive all the time. It can't always be positive, so I'm just gonna go with C. Entropy of the universe is always positive for a spontaneous process.